The purpose of this video is to explore the properties and applications of prime factorization. This topic in number sense can be explored in algebra and other mathematics topics. So let's say that your algebra teacher expects you to break down a number like 1024 without a calculator into its many factors. This process of prime factorization will help us accomplish this goal, as well as to find some other values like common factors and common multiples. As a review, prime numbers are quantities that only have factors of themselves in 1. In the chart at the bottom of the screen, you can see all of the numbers with blue background are considered prime numbers because you can only divide them by themselves in 1. We will use these numbers in the divisibility rules we've learned in a previous video to go through the process of prime factorization. Prime factorization breaks down larger numbers into smaller groups of prime factors. This process will allow us to determine lists of common factors, factor pairs, and common multiples, amongst other things in algebra and arithmetic. Please note before we go forward, the number 1 is not a prime number. It's not considered a prime number because it only has one factor itself. So let's go through a couple examples of prime factorization so you can understand the process. The first number we'll look at is 350. Let's use the process of working with the smallest prime numbers and going forward with our divisibility rules to break these numbers down as much as possible. So we can see that since this number is ending in 0, it is divisible by 2. Alright, so you can think of this as 2 times something, and we figure out that it is 175. 3 divided by 2 is 1 with a remainder of 1. 15 divided by 2 is 7 with a remainder of 1. 10 divided by 2 is 5. So we have 2 and 175. We recognize right away that 2 is a prime number, so I'll circle that in my factor tree. 175 is a larger number that we will try to break down. Now it's not even, so we can't divide it by 2. We test it with our rule for 3. 1 plus 7 plus 5 gives me 13, which is not divisible by 3, so we can't use that. Since we're not divisible by 2 or 3, you can try 4, but the last two digits, 75, are not divisible by 4, so 5 is the obvious next choice, which is something we can use because the last digit here is 5. So we break this down into 5 and something else. 5 goes into 17 3 times with a remainder of 2. 5 goes into 25 5 times. So we have 5 times 35 is 175. We see right away that 5 is a prime factor, so we can circle that. And 35, we know from our multiplication charts, we can break down even further into another 5 and 7. Now you'll notice both of these numbers at the end here, 5 and 7, are prime, so we cannot break things down any further, so we are done. This means that the prime factorization of the number 350 is 2 times 5 squared times 7. Notice that you could write 5 times 5 in the middle there, but it's much easier to write 5 squared as we go forward. Now this process will allow us to do a couple things. We can maneuver those numbers around and combine a few to find all of the factors of 350. We can look at this compared to other numbers and find common factors and common multiples, which we'll review in future videos. Our second example is the number 159. Now obviously this number is not even, so we can't break it down into 2 times something, but let's use our divisibility rule for 3 to see if we can break this down by a factor of 3. So 1 plus 5 plus 9, add those together and you get 15. 15 is divisible by 3, so is this number. So 3 goes into 15 5 times, 3 goes into 9 3 times. So we end up with 3 times 53. Okay? We obviously know that 3 is a prime number, and we look at 53. Now you could cheek back earlier in the video and see if this number is listed in blue on that chart, or you can try some more of the divisibility rules. You can try 5 and 4. They don't work. You could try 7. You could double the last number and subtract, but we would end up with a negative, so that doesn't work. So as you go through the process, you realize that this number is a prime number, so we are done. So the prime factorization isn't always a long process. You do want to make sure that you go through and test everything up to probably 11 is good enough. So the prime factorization of this number is 3 times 53. The larger and larger the examples get, the more you have to break them down into more prime factors. You are welcome to try to break them down in a different way than I'm going through, but I like to break down the prime factors in order just so that I don't miss anything. So I'll do the same thing here. I can see that we end in 0, so we have an even number here. So divide this by 2 and we get 630. Now I'll speed the process up because this is a little bit larger of a number. Again, 630 is an even number, so we'll divide it by 2 again and we get 2 times 315. Now 315 is obviously not even. We can use our divisibility rule for 3. 3 plus 1 plus 5. That gives me 9, which is divisible by 3. So is this number. 3 multiplied by 105 is 315. I repeat that process again. 1 plus 5 plus 0 is 6. 6 is divisible by 3, so is this number. So 3 multiplied by 35 is 105. Again, I recognize 35 from my list of multiplication charts, and I know that that is 5 times 7. Both of these numbers are prime, and I'm done. So even though we have a larger number, we can break them down quite easily as long as we know our first couple divisibility rules. So 1260 breaks down nicely into 2 squared times 3 squared times 5 times 7. So that's it. You'll see as we go forward that I'll use this process of prime factorization and my divisibility rules in a lot of applications such as least common multiple, greatest common factor, factor pairs for quadratic functions later on. The list goes on and on. We can see that breaking numbers down into smaller components can give us a lot of insight about larger numbers in general. Thank you so much for watching. Please continue to check my channel for more videos on mathematics and other topics in education. Thanks again so much for watching.